So we can formally start now. Good afternoon, good evening, good morning, depending on where you are located around the globe. We are in the breakout session 5, Linguistic and Disciplinary Barriers to Heritage Science and Data Interoperability. The initiative, the idea of this meeting comes from several European funded projects and initiatives, Hyperion HS, IRIS, the heritage infrastructure on heritage science, the research infrastructure on heritage science, Ariadne Plus project, and so forth. We have here, and you can see here a very short bio of the main speakers here. I will just mention the names, and then each one of you will talk later on. This is also the list how speakers will present their work. Carla Balzuvait, Juliana van der Leck, Renato Gonzalez Mayo, Wim Fermont, Franco Nicolucci, and then myself at the end. For those who are not directly related to the subject, I put up a definition of heritage science that will come up also later on in other presentations as well. The main subject is, as I mentioned, heritage science, which is the interdisciplinary domain of scientific study of heritage. And it draws on diverse humanities, sciences, and engineering disciplines, and it's an umbrella term encompassing all forms of scientific inquiry and works and the combined works of nature and humans. I will just mention very briefly IRIS and Hyperion HS and what they are. IRIS is a distributed research infrastructure, currently about 100 facilities from 29 countries, but it's still growing. And it regards a collection of advanced tools and services for and by interdisciplinary communities of researchers. It is a project in the European Strategy Forum on Research Infrastructures roadmap, and the roadmap itself is a list of areas strategic for EU science development. Since 2016, it is coordinated by the Italian National Council of Research. It is built around 4 main platforms: ArcLab, MoLab, FixLab, and DigiLab. And you can see here a list of the countries that participate, followers, which are both countries and international institutions, and also scientific contacts in various parts of the world. The mission of IRIS is to conduct research on heritage science and provide access to cutting-edge instruments and services, fostering advancements in heritage science. The mission is to operate at global level, and it targets interdisciplinary communities of users. Since this year, so this is the latest project was funded by the European Hyperion HS. You can see here the participating countries and their global distribution. Others contribute to a successful establishment. So this is IRIS and Hyperion HS. In order to introduce the subject more in depth, Catherine Schmidt-Patterson, who is Associate Scientist at the Getty Conservation Institute, kindly provided some more and is a conservation scientist regarding data and Getty. Researchers to have is the ability to link between data. So this is one of the most important requirements. And to find a way to build bridges between data across objects, across collections, and so forth. And this data can be of different sources, of different scopes, different analytical tools, over time, and findings to art conservationist the data. You use express of interest and know came from. Something happened. Hello?
I saw you lost you.
Yes, apparently somehow everything disconnected. Where did you lose me?
When you were talking about the pyramids, the first step
so
over
I
there.
will go back to the pyramid.
Yeah.
Yeah, okay. So, do you see it now?
No, it's the wrong page. Yes.
Yeah?
Yeah. We see the Zoom meeting. Yes.
Yeah, okay.
Now just, I think, a little one less.
Can I go now? Hello?
Yes, okay,
Yes.
go.
We hear you.
Yeah, well, I'm sorry, we have storms here actually, so maybe that causes the problem of the internet. So I mentioned that one of the most, not I, but Catherine mentioned that one of the most important requirements from data by scientists is the ability to share and link between data. And you see here what's the meaning of that. Then another very important requirement in terms of data analysis and interpretation is to know exactly from where a measurement comes from, make assessments on the quality of the data, and be able to reinterpret findings and add on top of already existing data. So in terms of management of data, access and IPR, researchers require access control based on object, user type, and so forth. And institutional policies may impact the degree of access granted. So here are types of access, and this is something very, very important for scientists and also others who are working with scientists. So IPR propagation, it's a very important issue that has to be considered. In terms of data organization and management, we are still in heritage science, we are at very basic, we are at the start because many institutions lack a single means of organizing data consistently using standards, control vocabularies, minimum metadata sets, and so forth. There are very few still institutions who have implemented a data management plan. There are protocols that still have to be discussed. What does it mean? How to document data provenance? and so forth. So there is a lot of work to do also in this domain. So I will now stop sharing my screen, and I will okay. I will give my word to Carla.
Okay, thank
Please.
you, Soren. Let's share the screen now. Okay. Well, good afternoon, everyone, or good morning, or good evening to people in the other time zones. My name, my name is Carla Balsowait from the Federal University of Minas Gerais in Brazil, and also Antecipa, which is our Cultural Heritage Association. And together with a colleague from FORTH, Greece, Yanis Tsitsikas, we just put together a very small presentation on some of the IT barriers to heritage science data interoperability. Quite recently, Antecipa, which is a national association which congregates people from all over the country and Brazil and different institutions, were invited by Hyperion, which is a European facility institution, to start the discussions or to participate into the discussions and the implementations of DigiLab. As Soren showed, other partners were also invited. So you see that we are not only very broad geographically, but if you go into heritage science, we have a lot of very different institutions working on heritage science, from tiny museums, large museums, universities, research institutes, laboratories, also police departments and public ministry, and many, many other ones. But we also have a very different types of people working on cultural heritage with different backgrounds and ways of thinking, so that we go from all the humanities into the hard sciences. And when we have a look at the techniques which are being used in cultural heritage, you see that it's a lot of them, and the ones which are mentioned here are just a part of the techniques which are available in Hyperion HFS catalog. So you see that the challenges are quite large. And if we focus a little bit onto IT, we end up with something on best practices, standards, protocols, of course, data and metadata typed. But we also have to be aware if we are using a certain technique and different equipments are used, either old or new or commercial or homemade, the data output will probably be a little bit different. We also have open software, proprietary software, black boxes, and last but not least, our upcoming problem of storage, which is probably not only a problem in cultural heritage, but in different areas. So if we start with some initial surveys, we see that some initiatives are also happening, already happening in cultural heritage, and also some national platforms are already available. But when we go back to our data, or metadata, which is data about data, and get into the Wikipedia, we see that there are many different types of metadata. But not only that, we also have very different standards which are used by the community. And then what we have is that some standards are already very well established, like, for example, standards for the structural data, which is essentially the position of atoms in crystalline material or in any phase that you can find in nature, which is the crystallographic information file, which was created in 1991 under UCR, the International Union of Crystallography. And this data, which is gathered in different measurements, so that we can find, for example, a titanium oxide, which is a very well-known white pigment, has different forms that the atoms are organized. And there are very specific numbers or CIF codes or CIF files that you can have exactly that phase. So those numbers will be used or will be created not only by the scientists who have studied that structure, but will also be further used for interpretation and simulation in all types of diffraction techniques which are available. But when we go to some other areas, for example, in the scanning electron microscopy for a quantitative EDS analysis, which essentially will show what elements are present in the sample, and you are able also to quantify those elements, we see that there is no standard way of getting all the data and to repeat that yet, because we have the sample history and sample preparation that are needed, the data acquisition where we have good practices and we have ISO and ASTM rules, but not everybody is able to access them. We also need the manual of the equipment, correct choices of parameters, and calibration made correctly. And the data which we get from the equipment is normally given out in proprietary format metadata. We also have already 2 open metadata formats, and most of those proprietary formats can be transformed into that. But if we want to quantify, we still have some more parts into that equation, which are the matrix correction, and sometimes different models can be used to that, different background adjustment. So that's something that is not easy, and we can see an example of that on interlaboratorial tests on a sample of germanium, nickel, yttrium. We see that one analysis was perfect, and we see the mass normalized here, and the unnormalized data is here. So the quantification here is completely correct. But we also see that measurement here, which the quantification normalized, okay, it seems nice, but we have a problem here. And that problem is that the sample, or this part of the sample, was just not flat. It followed all other protocols and good practices. And the trouble is that depending on your software version, you might not have the access to unnormalized data. So you have no clue whatever if you are not very well aware and careful about the flatness of your sample. And several details can give you a problem on that. Well, then we have also a little problem, which I just put here in a very simple way, translation. And that data was just got from Google Translator, where we get spring into spring. But in Portuguese, the names are different. And in German, the names are different also. So it means that Google Translator goes over English to translate different languages. What's the problem? Words and expressions do have meanings and data too. So this is a very small example in a physics undergrad book where a lead oboe has been translated into a lead oboe just because, well, it's science. So poor musician, that is probably a very, very heavy oboe. So there is a need for expert knowledge and more sophisticated algorithms to do a proper translation. Then we come into another aspect, which has been enabled by us from a very technological developments, where instead of just image acquisition, we are nowadays able to get a whole spectra of each pixel of that image. So, or a whole image, for example, a diffraction pattern. And so we start working with what we call data cubes, where we have 3D or 4D or ND types of data. If we go for a spectra, it's just 1D, a normal image, XY, it's a 2D. So we have a spectra, or we might have an image for each pixel, or we might have time. So if we have a look onto computer time and computer storage, we go from, for example, a simple spectra into a fourfold cube. And so we end up with one file, only 8,000 terabytes. So that's something that is not easy to treat. For example, if you need to treat the data in a computer, but also storage. So how we access all those data and how we work with that. So we have to think about very modern ideas of treating that data or acquiring that data, which goes through big data or artificial intelligence, but also some different formats and ways of browsing into that data. But one big question still remains is who load all these data? But because a possibility to achieve interoperability across all those plethora of data is an ontology-based integration. And one possibility is CDOC CRM, which has been produced to integrate hundreds of metadata of schemes. It aims at putting together all relevant sources of data to evaluate questions not answered by a single document. So we see that several components are required to achieve ontology-based integration. And here only the main ones are summarized. An example is a triple search for El Brachio Museum, where we have different entities, graphs, question and answer, and schema to be able to retrieve all information available in the internet about the El Brachio Museum. And if all metadata is then transformed into ontology-based metadata, a suite of services can be offered that can tackle various requirements. And here we have some state-of-the-art components or systems that can tackle these requirements. Essentially, all of them are needed, but some methods do not presuppose harmonization. On the other hand, there are some methods which do to be effective. So we come back to our idea that Soren introduced of the GGLab, where one of the ideas is that data is sent to expert laboratories and then treated and returned to clients. But that not only goes on how you query that data, but on how you acquire the data, or if you have enough data. Licensing issues are a big problem. Data storage, of course, and probably some unknown problems which we do not know yet. So perspectives go very through multiple solutions, which need to involve people with different backgrounds, techniques, institutions, multidisciplinary, IT challenges, which are not small. That means just a lot of work. So I wanted to thank you, and I know it's a very fast presentation, but just to get a flavor of which are not few and not very small. But I would like to acknowledge my colleagues at Anticipa, especially Luis de Souza and Willy. Without them, I would not just be here. Also, all the colleagues in the DigiLab task forces, the group, I would say it's about 50 and 60 people, and especially Lucas, Soren, Marco, Josef, and Wim. But also thank the Center of Microscopy, which I helped to create, and my university, and finally our funding agencies, without whom it would just not be possible to do any research. So I thank you the attention of all.
Okay, thank you very much, Carla. I suggest we go one by one to hear the presentations, and then at the end we will open the floor for discussion. So let me just also open the video. So I would like to invite Juliana now to present her talk.
Yes, hello everybody. Thank you for inviting me. I'm going to try to share my screen. Can you hear me all right?
Loud and clear.
Okay, yep. Great, because my internet connection is very poor today. Okay, share. Okay. Okay, so let me start. I'm Juliana van der Lek. I'm a project coordinator at Clarin Erik. And I'm actually coordinating this new initiative that Clarin took to collect and register vocabularies in social sciences and humanities. I've prepared this presentation with my colleague Dan Bruder, who is also a project manager at Clarin Erik. First, I would like to give you a short introduction into the SHOCK project. It is a Horizon 2020 project funded by the European Union, whose main objectives is to create the social sciences and humanities part of the European Open Science Cloud, to maximize reuse through open science and fair, to maximize reuse of data, of course, through open science and fair principles, interconnect existing and new infrastructures, and establish appropriate governance models for SSH. As you know, and as also the previous presenter highlighted, SSH is a very broad field with diverse research methods and practices. This has also led to a diversity in the way vocabularies are used to describe, discover, and access research contents. Since SHOCK aims to improve the conditions for sharing and optimizing research data and services in a sustainable way across domains, Clarin took the initiative not only to collect, harmonize, register and harmonize the most used SSH vocabularies, but also find a sustainable vocabulary hosting and management platform. Hopefully, this initiative will enable a more unified access to research contents and also contribute to the development of the SSH area of EOSC. This vocabulary initiative complements the work, some work that has already been done by Work Package 3 in the SHOCK project, which aims to develop and integrate a set of tools and services for managing and processing research data based on existing tools and interoperability requirements. For example, the Clarin Switchboard, a platform that can help you find data processing tools, has been integrated in a number of SSH data catalogs, such as the data catalog for archaeology and the text grid repository, for example. So how have we approached this initiative? As a first step, we collected the requirements for the vocabulary registry. During the first year of the SHOCK project, Work Package 3 has already provided a review of the main vocabulary platforms and also identified the technical requirements, which I'm going to present in the next slides. As a second step, we organized in September a series of virtual information sessions to raise awareness in the SSH community about vocabulary platforms. Experts presented concrete use cases about the implementation of Wikibase, Cosmos, and the SESTA vocabulary service. They shared best practices and the advantages and disadvantages of using these free platforms. Then early November, we also organized a more in-depth workshop where we discussed the preliminary recommendations for vocabulary platforms. And you have the link, via this link, you can access the presentations and recordings later on. So what have we learned about vocabularies so far? Some vocabularies might not provide full domain coverage or lack concept definitions and examples. When you find a good vocabulary, of course, it's not really sure if you're able to reuse that because the data model might not be the same, which raises barriers for harmonization, search, and link of other vocabularies across domains. At Clarin, we believe that some of the interoperability challenges could be addressed by reusing existing vocabularies wherever possible, and also rely on the vocabularies that have already been curated by libraries and that link to authority files wherever possible. Other challenges that we have noticed are the level of maintenance and quality control, quality assessment, and making these vocabularies available in translation and authoring environments. I have to point out that we mainly focus on controlled vocabularies, taxonomies, and thesauri. I'm not sure yet if we will also create an inventory of ontologies. During the virtual workshop we organized early November, we were wondering whether we could address some of the challenges by applying the FAIR principle, which focuses, of course, on the semantic aspects of interoperability. One of the panelists suggested to have, for example, the A from FAIR stand for adaptable instead of accessible, because both vocabularies and the platforms that are hosting them should be flexible and easy to adapt to new changes. Hence, after we have cataloged the vocabularies, we will try to provide documentation, use cases, search facilities, and properly identify the artifacts and metadata. And of course, finally store them in a certified repository. I've already started collecting and describe some of the SSH vocabularies. The attributes still need to be finalized, and through survey and interviews, we will collect the most used vocabularies in SSH. As far as the vocabulary platforms are concerned, they come with their own technical challenges, which you can view them here. At Clarin, we believe that, for example, a potential alignment between different vocabulary platforms could be realized by multi-directional synchronization to avoid double curation work and facilitate a compatible access APIs for different systems. During the first year of the SHOCK project, Work Package 3 has provided a review of existing vocabulary platforms, which you can, which I have listed here. And insights have been collected in a milestone report. Ideally, the platform storing the SHOCK vocabulary registry should be an open source SaaS solution supporting interoperability protocols such as RDF, API, and SparkQL for linked data. The source code should be available on GitHub and available for everybody. And if you're interested in an overview, here is the link where you can access the spreadsheet. Here you can see the set of features and functionalities that we have identified for the SHOCK vocabulary platform based on the research done so far. Additionally, effective strategies need to be set in place for the curation and maintenance of vocabularies, as well as a defined governance and sustainable model once the platform has been identified. So, which platform platforms meet the requirements identified so far. The Clarin vocabulary service, which currently uses Clavas to store and manage vocabularies. We are currently looking for a new platform because we try to move away from open source. And then we have CESDA vocabulary service, which is also has a very nice browsing and a very nice editor and browsing functionality. And an API, it's on the way for CESDA. And then the last candidate is the ACTH vocabulary service, which is based on Scosmos. This one is used by Daria to manage vocabularies, has also an editor, uses Cosmos to publish the vocabularies, and supports multilinguality and import exports of different formats. So what are the next steps? We will build on existing inventories as much as possible and try to come up maybe with a final recommendation for the SHOC vocabulary hosting platform. We don't know yet if there will be only one platform or more platform or a mixed solution. So we still need to investigate. And we'll try to further develop our inventory of known vocabularies with their metadata, provide guidelines for the harmonization of metadata, and of course, harmonize the metadata in the end. And I'm closing the presentation with some useful links to the Clarin Virtual Concept Registry. For those of you who don't know it, please have a look. Maybe you find it useful. And the Clarin Language Resource Switchboard that we used in SHOC, for example, to which we have integrated in the Ariadne Visual Media Service. And yeah, that's about it.
Okay. Thank you very much. Thank you, Juliana.
Yes.
We will, if you can wait until, yeah, please go ahead.
Yeah. No, I just wanted to say that if you're interested in collaboration, if you have experience with vocabulary management platforms and you'd like to share best practices, please don't hesitate to contact me.
Okay, thank you very much, Juliana. If you can wait until the end of the session, we will have a discussion. Yes. It's planned, and we'll see how much time we'll have. And I will pass now the word to Renato, please.
Thank you. I'll share my screen. Does it look fine? Let me start by expressing my gratitude to the Hyperion project for this invitation. I am really an art historian who got interested in both material art history and as well in organized information. My specialty is Mexican mural painting from the Revolution. So I hope what I'll say is useful for the purposes of this table. I would like to acknowledge significant input from my colleagues Claudio Molina, Sandra Centina, and Jose Luis Rubalcaba. Maybe because in Mexico, we have worked hard just to reach an acceptable practice of digital cataloging, I will depict the building of information systems as a pyramid. The tip of the building is metadata on scientific data, the nirvana, interoperable and ready for the semantic web. Just below that, information about instruments and the digital documents they produce should be organized. That's the stage we are starting to work on now in Mexico. And then we have the base of the pyramid, the digital catalogs or inventories of cultural heritage at large. Linguistic issues regarding the cataloging of heritage and problems related to scientific documentation, instrumentation, and data should be addressed with different criteria. Scientific data and documentation is stored and shared primarily in English. English is already a lingua franca for science, so students, researchers, and specialists are familiar with a technical lexicon to carry out their goals. Specialized vocabulary, I have to say, full of acronyms. Scientific methodologies are, to a large extent, explicit and quite controlled. So the reasonable path to follow would be to develop authoritative files for instruments, methodologies, and data types before engaging in the task of translating them to some sort of multilingual system. To say it in lexicological terms, we need prescriptive dictionaries for this kind of data. Dictionaries that indicate a preferred term, authoritative files being super prescriptive vocabularies, if you allow me to use this somehow obsolete notion. Things change a lot if we go to the base of the pyramid. To make a brief statement, we need descriptive, not prescriptive dictionaries to address heritage cataloging in a way that might be more productive to scientific research. Differently from the scientific data, technical data for the cataloging of artworks, archaeological items, or monuments is largely a cultural problem. See the expression oil on canvas. More often than not, material scientists will show how inaccurate this is, oil being all sorts of materials. Let me be concrete. There is a painting by David Alfaro Siqueiros, Mexican painter, Proletarian Victim, 1933, painted in Montevideo, property of George Gershwin, and which belongs to New York's Museum of Modern Art since the late 1930s. While in South America, Siqueiros envisioned the possibility of using modern synthetic materials in his painting, and he was told about the new Duco by DuPont. So he started looking for the supermodern Duco, the pyroxylene that had been worked out by the chemical industry to convert the production of World War I explosives. Now, the explosive potential of cellulose nitrate and also the fact that it was used to paint cars awakened the futuristic sympathies of Siqueiros. A war paint, a speedy paint for speedy cars. Wow. So he painted Proletarian Victim. As early as 1934, it was included in MoMA's 5th anniversary exhibition with a catalog entry record that said, Duco paint on burlap. Imagine the sensation in 1934, Siqueiros' painting hanging next to Giacomo Balla's Dynamism of a Dog on a Leash, when the supermodern MoMA's patrons would vote to read the label and find, instead of the revered oil on canvas and a text about an industrial paint on an industrial fabric, in sheer contradiction to the painting's expressionist style. The problem is, Siqueiros was not really truthful about this. In the years 2000 and something, gas chromatography mass spectroscopy combined with FTIR analysis was carried on Proletarian Victim by New York MoMA's Chris McClinchy and Annie Abiram in a study co-authored by Mexico's UNAM Laboratorio de Diagnóstico de Obras de Arte with Sandra Cetina, José Luis Rubalcaba, and Elsa Arroyo. The results published in 2013, quote, detected fatty acids which indicate the presence of only an oil medium throughout the painting and overpaint, end quote. No trace of cellulose nitrate. The public record of the work has changed since to acknowledge enamel on burlap. There would be a lot to say about the use of enamel instead of oil painting. But I want to stress the difficulty to build a system of equivalences from this very simple story. Even if the AAT dictionary makes a fairly convincing translation of enamel to esmalte, Duco is a more difficult matter. The Mexican custom prefers, as recommended by the Getty's Cataloging Cultural Objects Manual, the more general expression pyroxylene. The expression Siqueiros also preferred from the 1950s on. He might have come to realize that Duco was a trademark belonging to a multinational corporation. Although the problem here is for technical matters, technical vocabularies have significant differences between countries and even between regions that speak the same language. Lexicological work is not as developed for every technique as in other areas. At least it is not in Spanish, because there are several countries speaking the same language here. It is here that the most significant effort should be made to tear down the linguistic wall. Even if we are fortunate to have some pre-existing dictionaries of the highest quality, an effort is recommended to develop native language, specialized dictionaries or vocabularies from ground up, that is to say, not only translation, but based on sources both written and ethnographic. In short, descriptive dictionaries is what we need. One can imagine, with the very sophisticated standards we can use now, that a field to be captured using an authority file might be useful for some heritage institutions. However, the idea to normalize different traditions to speak of technique, either belonging to the same or different languages, seems neither desirable nor feasible. It is clear from the example above that there is no confusion to be feared from acronyms such as GCMS or FTIR. Any lab assistant will recognize those initials and will look for them. Should we have to translate the acronym for, in Spanish, FTIR, espectrografía infrarroja con transformada de Fourier, to EITF, it is likely that nobody would understand. Instead, the fact that Siqueiros clearly described the material in his work as Duco, and it was so considered for years, raises a different set of problems. It is crucial to recognize that more often than not, information provided by modern or contemporary artists belong more to the title than to the material characterization. Title has always been treated as a literary small text of sorts, a paratext, to use the Peter Wagner's terminology. It is my contention here that an effort should be made to make clear the source and scope of the technique line as well, using also the critical tools similar to those of literary research. Of course, I do not pretend that such exercise might correct the scientific data. But however mistaken, either purposely, as in this case, or in naivete, the technical information provided by the artist, in this case, the mistaken notion that the painting was cellulose nitrate or Duco, is relevant for cultural and historical reasons. So I claim that even though we might come to a multilingual system for scientific data, the priority is to address two problems in the apparently simple technique line in the very base of the pyramid. This is not only data that needs multilingual tools, some of them already exist, as in the Spanish translation of the Getty Art and Architecture Thesaurus. Also, whatever the language, we have the two cultures theorized by Charles Percy Snow conflicting on a simple line or database field, because historians will look at it as a paratext and as such related to the general significance of the object. Not always susceptible to correction, while heritage scientists will try to make the best effort to make that line as truthful as possible to the material reality. These should become complementary paths to information and research, and not competing cultures over the same cultural object. I'd resort here to Bruno Latour's remark on this matter. There's never been a war between the two cultures. Thank you very much.
Thank you, Renato. I would like now to invite Wim to present his talk.
Hi, do you see my screen?
Yes.
Yep. Okay. Good morning or good evening, everyone. And thank you, Sorin, for introducing me. In this presentation, I will give a short overview of the barriers, the challenges that we face in terms of interoperability in our diverse community. And before discussing these challenges, it might be necessary to precisely understand what heritage science is and what data is created and how it is used. It was not until the last decade that the term heritage science became commonplace, and up until a few years ago, there wasn't even a definition. ERIS, the European Research Infrastructure for Heritage Science, did come up with this definition, which is now also on Wikipedia. It's the interdisciplinary domain of scientific study of heritage and involves humanities, science, and engineering, and probably even more disciplines. The interdisciplinary nature of this community is evidently enriching, but makes sometimes communication difficult. Heritage science is a very broad domain, encompassing, as Wikipedia states, all forms of scientific inquiry into human works and the combined works of nature and humans. Some concrete examples why scientific examinations in heritage science are done are, for example, quite often scientific examination is requested to assess the conservation state of an object that is being conserved or restored. The results of this scientific examinations are one of the most important, if not the most important factor in choosing the most appropriate treatments or procedures. Scientific examination can also help to identify the materials and reveal the production techniques of objects, or reveal the provenance of the raw materials, which can then be used to retrace trade routes and influences. We apply several techniques to date the materials, such as dendrochronology, carbon dating, and other techniques. And identification, provenance, and dating techniques are often used to give an indication about the authenticity of an object. You understand that these are research questions to which scientists of different disciplines are contributing. But they are faced with a number of barriers that make communication between them difficult. In some cases, these issues can be overcome and are related to IT barriers, such as the ones that were discussed by Carla previously. And first example of a barrier is that all researchers produce output in some way, and there are many types of data and many formats, and interoperability is hampered by this multitude in data that is not always easy for other researchers to understand and to interpret. In the disciplines involved in heritage science, there are different and sometimes incompatible research data management practices, ways to describe, document, store, and share the data. And these differences make access to the data more difficult. Maybe not directly related to interdisciplinary barriers, but sometimes the communication of heritage science results and the possibilities to publish these are made difficult by intellectual property rights and right agreements on the studied objects themselves. And finally, much of the metadata that is considered required for one researcher is considered as bloat for another. A restorer is likely not interested in the instrumental parameters used in physicochemical analysis, but rather in the interpretation of those results in the context of the conservation procedure. I'm quite sure that the heritage science community is not the only one confronted with these problems, but I'm curious how other interdisciplinary communities cope with this. Most of the barriers can be overcome by thoroughly documenting analytical examinations in a standardized way. To document the study in conservation science, many aspects have to be taken in consideration. This starts with describing the reason for the examination, documenting its place in the pre-existing information of the object or theme that is being studied. So why we are doing this and what are the unanswered questions that we are trying to solve. And this goes on in the description of initial observations and the choice of the methods that we are going to use for the examination. In many cases, the solution will require a multi-instrument approach, each of them revealing only small pieces, and only the combination of those techniques will allow us to solve the jigsaw puzzle. Each of those devices need to be documented in terms of setup, initial settings, software used, parameters, and so on. The data and outcomes need to be documented separately for each measurement or device, and then integrated into overall conclusions and reports. This is a long list, but the process can be roughly divided into 4 parts. The first is a description of the objects that are studied, the artworks or artifacts. And this needs to be done in a way that everyone creating or consulting the data will interpret and use this in the same way. CDOC-CRM is an extensible ontology for concepts and information in cultural heritage and should be perfectly suited to do this. CDOC-CRM can also be used to describe sampling and analytical techniques. This gives an overview of what is done in a particular project. The applied protocols and instrument parameters are more difficult to describe. There are a number of standards in heritage science for specific techniques, but not a single model that fits the needs for all techniques used in the domain. On the other hand, outside of our domain, there are a lot of other initiatives that aim to do the same thing for their domain. But seldomly they can be applied as such on heritage science. A pragmatic solution that is sometimes heard is to create a protocol document that describes in full the measurement procedures. The reasoning behind this pragmatic solution is that this part of the information is only of real interest to scientists that know how to interpret them, not to the larger community. And finally, the interpreted data, the conclusions that need to be understandable by the whole community, these will need to be done with controlled vocabularies. In Hyperion HS, there is a task working on interoperability of instrumentation and digital documentation, and that will, as I think, mainly focus on the third point, so on the protocols and instrument parameters. I mentioned CDOC-CRM already in the previous slide. It will play a crucial role in the interoperability, and this ontology has several extensions that can be used if necessary to describe heritage science in detail. Scientific observation model, CRM SCI, SCI, is an ontology that to be used as a schema for integrating metadata about scientific observation, measurements, and process data. CRM Digital provides provenance metadata model. CRM Archio provides an excavation model for archaeological studies. And CRM PE, the Parthenos entities, provides a model for research infrastructure management. And there are a number of other ontologies or CDOC-CRM extensions that could be mentioned here as well. These diagrams show how a technical examination can be described in a general way on the left, and for a specific model method, Raman spectroscopy, on the right. It is obvious that such a complete documentation of an examination is a huge task and may be perceived as too complex and time-consuming. The scientists that create the data do not always see the benefit of describing the data set into such a great detail. With lots of things they see as trivial, but may not be as trivial for others. We risk that scientists will not supply all the required metadata and paradata. IRAC provides us with a good example. IRAC stands for Infrared and Raman Users Group and is a group of heritage scientists working on those two instruments. For many years, they are trying to compile spectral libraries of infrared and Raman spectra of reference materials. They came up with a model for metadata that is embedded together with spectral data itself into a JCamp, a DX file. The metadata is shown here in red. The data itself, or part of it, is shown in blue, and this goes on below the screen. If you cannot read this, don't worry. It's just to show how much metadata has to be supplied. In the beginning, this had to be completed manually in a text editor before submission. And they faced two problems. First, few submissions because it was too much work. And secondly, the files that were supplied were often incomplete. Since a few years, they have an online submission tool that facilitates the process. It's now possible to create templates, which many of the metadata can be stored in, that does not change often. So it's essential to keep things manageable for the contributors. Besides templates, pre-filled forms, also mappings and transformations of datasets might be part of the solution. This avoids that things have to be detailed and over again in the entry software. Parts of the metadata that are already stored in other systems or databases can then be extracted and mapped into the repository. A leveled approach might also be a solution in which metadata is categorized from essential, the upper part, which is required, to less essential optional layers. At least the essential descriptions will then always be present. In this way, the more vigorous scientist can go all the way while not putting off the more lazy scientists. Still, this approach does not overcome the risk of creating incomparable data sets. The Heskida project in Belgium aims to develop a repository for heritage science. In addition to our existing ATLib collection management system, which holds our library collection, a database of people and institutions involved in cultural heritage, and our vast photo library, we are setting up a platform to store and disseminate our data collected during conservation, restoration, and technical examination. Each sample, each photo, each measurement, and each document will be stored and documented independently in the repository. All data, whether stored in ATLib, IIIF for the images, or the repository, will be interlinked. Our search platform Ballot will bring everything together and show the whole context of the research. This way, the documentation task, still using templates, will be divided into smaller manageable pieces and entering exactly the same contexts again, over and over again, to each measurement is avoided this way. Many scientists with different backgrounds work together at GKEPA on a single intervention file, and each of them contributes data and metadata in its own fields of competence. We hope that this way we can overcome most of the interdisciplinary barriers. The HSKDA project aims to become the heritage science repository for Belgium, but our goal is not only provide the data in our repository through our ballot web application, but also contribute to the DigiLab platform of ARIS that will create and host tools to search and harvest data, not only for Belgium, but also from other repositories in Europe and maybe even worldwide. These repositories do not necessarily have to speak exactly the same language, as long as the information can be adapted and mapped and vocabularies can be used on them. What DigiLab exactly should become is being discussed at the moment in the DigiLab work group. A lot of experience exists in the ARIS network, but we must have a peek at other communities who did this endeavor before us, and I'm sure we are not alone out there. Thank you for your attention.
Okay, thank you very much, Wim. I will pass now this screen sharing to Franco.
Yeah, thank you. I'm going to share it. Okay, so thank you for inviting me to this workshop. And when I saw the agenda, I thought that after 1 hour, an online workshop would be tiresome. So I tried to make presentation a bit light-hearted. It doesn't mean that there are no concepts behind, but just to give you some relief from a flow of very interesting information. And that's why I chose this kind of joking title. Oh, just a moment, okay. So why is I call it a three-legged stool? Because interoperability relies on 3 pillars: standards for data and procedures, ontologies for concepts, and vocabularies for terms. Today or tonight or this morning, according to your time zone, we are discussing about vocabulary, so I will focus on the pitfalls that may happen, and if something fails, the stool is not so comfortable to sit upon it, as you can see in the second picture. I must tell you that the work we have done in Ariadne, in the Ariadne Plus project, and what I will go to briefly report in this 9-minute presentation, let me start a stopwatch, is starts from outside the laboratory's door. So we decided that the flow of data is continuous and we need to start managing it. And start in parallel working about what happens inside the laboratory. We consider that most of the standards used there are established or widely accepted. Carla in her presentation showed that this is not the case, but we were afraid that if we started to addressing too many issues, it would end like for the First Punic War, while they were discussing in Rome, Hannibal conquered the city of Saguntum. So we working with our colleagues, we are lucky in Ariadne because we have 41 partners from Europe and from all over the world. And they come from different perspectives. There are researchers, archaeologists mainly. There is people working in the laboratory, so working on archaeological science, which are very similar to heritage science. I think we can almost identify these 2 categories. And computer people, computer science people. So we can carry out the discussion in-house. And we developed an extension of the CRM standard, which Wim already introduced, suitable for managing heritage science data. It puts together classes from and properties from the different flavors of CRM he already mentioned. And it has 20 classes and 45 properties, including people, procedures, study objects, samples, device and software, dataset, and so on. It is already adopted in Ariadne. It's being experimented. It was finished a couple of months ago. And above all, it is implemented in our scientific data repository, DH Lab, which is allows to store there at this repository or at copies within partners, the documentation of scientific activity. And of course, there are already repositories around Europe and probably around the world, and mappings from the structure of these repositories are being undertaken, I would say rather successfully. We had a workshop in September where different approaches were considered and they are being addressed. And also this ontology is used in the text mining service we have developed, which is called TextCrowd 3 because it's the third of its kind. The others came from previous work. To integrate scientific data with heritage reports and other textual documentation. You can find the documentation here, and you can access all this information from the Ariadne Plus website, which is Ariadne Plus infrastructure.eu. You can easily find the links. This is a diagram of the ontology, but I will not spend more time on it because I have, the clock is ticking. Of course, this is documented in what I mentioned. Concerning vocabularies, we have started from existing vocabularies and gazetteers. They are well known. Wikidata for common terms, Getty, Ars and Architecture Thesaurus for the specific terms, GeoNames as a gazetteer, and BoF and Oxide to identify people. It's not written here, but Wim make an interesting observation that we must not bother scientists with too complicate input procedure. This is achieved in the DH Lab, which I mentioned in the previous slide, because you can reuse the terms. So if you are carrying out a campaign on the painting, on the Uffizi paintings, you will not need to rewrite that you're working at Uffizi. You write once for all. And also, if you make different data acquisition using a specific device, you mention once for all. So it's just specifying time and what we're doing now, reusing the information already included, and then collecting automatically the data coming from the instrument. There are issues, as I said, and here I present three typical ones. I apologize for using European examples to our American colleagues, but they had them at hand, so they were easily usable. The first issue is concerning named periods. How do you convert Roman age into a time period? Well, this is very difficult. You can see from this diagram here that these are different. It was developed years ago by the Arena project, that in different countries, the Roman period, which is something like this bluish thing, occupies different time spans. So when in Romania, there was a the Roman period, in some other countries where, for instance, in the Nordic countries where Romans never arrived, there is no Roman period. And the periodo system provides an organized solutions for such name period, because they depend on where. Similarly, geographic names depend on when. So a statement like Egyptian blue was widely used in the Roman Empire is, well, does not give you a specific information if in the Lutetia Palesiorum they used the Egyptian blue, which is, as you well know, probably is a blue pigment developed in Egypt in the beginning and then spreading around Europe. And the map shows that the Roman Empire has different locations according to the time. Then there is an issue with terms. Some years ago, I was in the UK discussing with colleagues and trying to explain them Nastrino. What is a Nastrino? Sorry, I have to go back here. Yeah. And they, after hours of discussion and showing images and so on, they told me, but we don't consider that. We don't consider that an architectural feature. So you don't translate. You cannot translate. You have no equivalent because there is no equivalent concept, and the solution is ignored. By the way, Nastrino is this part of a ashlar facade. So these are the ashlars, and these lines here in Italian history of architecture are called Nastrino, which in English is a small ribbon. And in UK they don't consider. So also the multilinguality has to face issue of missing terms beside the multiple meanings that Carla already introduced. And by the way, give me a last joke. If you want to include stool in a vocabulary, it occupies some part if it is a vocabulary of furniture. So it's a specification of chair, which is a part of the furniture, part of the vocabulary. In a medical vocabulary, it would occupy a completely different position. So, jokingly, and I hope that nobody will regret about this statement, I rephrased the famous quote by Clemenceau: terminology, it is a too serious matter to entrust it to linguists. And with this, I have finished my presentation just in time as promised, 1 minute more. I hope you enjoyed the joking part and you got some interesting insight into the more serious ones. Okay.
Okay. Thank you, Franco. I still have problems with my internet, so I will try to shorten my presentation. We had some very interesting topics that I hope we will be able to have some time to discuss them as well. I will just now want to present very briefly the concept of DigiLab in IRIS and in Hyperion AGS, and what we would like to do and where we would like to go, without entering in any kind of technical details about it. So I hope that you can see my screen and you can hear me well. DigiLab consists of research facilities as same as FixLab, MoLab, ArcLab, and it is devoted to the study of heritage by means of integrated heritage science and humanities digital data. So this is very important to understand that DigiLab is not a data repository only, but it's actually an environment where researchers can conduct their research. Moreover, what is very important is that, as it is envisioned, the research is done in tandem, and I'm using the tandem word from Franco, so I have to give him the credit for that, in tandem between researchers in chemistry, physics, heritage sciences themselves, and researchers from the art history, archaeology, cultural heritage studies as well. So based on that, DigiLab offers access to digital services and research tools. So not only data, but actually tools to use, expertise, and resources. The data itself should be provided initially by FixLab and MoLab, but later on also by other researchers, institutions, and so forth. It has to be curated according to the FAIR data principles and enable interoperability, which we all heard that it's a key requirement from many, many researchers. DigiLab should also provide a virtual research environment where researchers can bring in data, analyze it, visualize it, interrogate it, and manipulate it, with the final goal to create new heritage-related knowledge. So, of course, it has to follow the FAIR data principles, but one who looks very carefully on these principles and they will realize that there is no address at all about data quality. And data quality is actually one of the major requirements from heritage science data, I'm sure also in other disciplines. But we have to see how we are addressing this issue and going beyond the FAIR data principles there. Of course, we have to align with EOSC, the European Open Science Cloud, RDA, ESRI, and so forth. And we should consider and never forget that our work is done together with archaeological research, art historical research, conservation, restoration, development of methodologies. Carla showed very nicely the very broad spectrum of our work. And also, as reflected in our workshop here, DigiLab should have a global perspective. I brought also here an example of a heritage science workflow. I will not bother too much with it because we heard we heard this or the other presenters before. What I want to highlight, and it has been also mentioned before, that any research starts with questions that may derive from art history, conservation, restoration, authentication, and so forth. Then we choose methods, protocols that exist based on the instruments and the data and the interpretation itself. And here you have some examples of the instrumentation that can be used, which is very, very diverse and includes digital, imaging, chemical, optical, and so forth. This is another example of an interrogation pipeline where we go from macro to micro using a lot of methods. And again, I make reference to Carla's very nice diagram showing the multitude of methods used in heritage science. Also, Wim mentioned that as well. So, coming to DigiLab, the conceptual minimal viable structure is that it has a data repository and a virtual research environment. DigiLab should be able to allow enrichment of the data, and it should also provide a catalog of services, and it should host a reference collection. We heard before also various attempts of groups of interest groups. The Raman was mentioned, the microscopy mentioned by Carla. There are many, many reference collections that eventually should be hosted by DigiLab as well. So in terms of the process itself of DigiLab, it has an ingestion, curation, interpretation, and publication. Here I go into a bit more details about it. The ingestion should allow managing and absorbing and hosting different types of metadata. We heard also before about them, technical metadata, but also paradata. This is something very, very important, and it has a direct reference to data quality and data provenance. So how data was collected, which protocols have been used, if they were used, there was any data management plan, and so forth. Then it is crucial that we should have information about the object analyzed in terms of its art historical background, archaeological or historical. Then a process of data cleaning should occur, we mentioned the problem of inconsistencies in data, incompleteness of data. So this is something that has to be addressed. Data ethics, it's very important regarding IPR and related issues. Then we move to the storage itself, and we need to have an indexing system, particularly when we are talking about federated repositories. We should be able to give a versioning to the data, and very important, mentioned also before by Carl, I think, the separation between or the identification of raw data, processed data, or derivative data. Then we should be very careful about how data is accessed, and Catherine highlighted that very well in terms of authorizations, levels of access, and so forth. The system should allow semantic search, intelligent browsing, a very flexible data retrieval system, and of course, mapping between existing metadata schemas, and of course, solving issues related to thesauri, vocabularies, and Juliana made a very nice overview of the challenges regarding thesauri and vocabularies. A very important aspect that we should consider is, okay, once we have all this data, what do we do with it? And we should be able to create a virtual research environment, possibly having a dashboard where we bring data and we manipulate it in various ways. The creation of a collaborative environment where we have a meeting room between various researchers where annotate it and perform various analyses on them. So I put here just a list of various for exploring data. Carla mentioned data sciences as well. So several years ago, in another preliminary project, the software developed aim of having an environment where non-invasive and the whole MOVDA was developed. And you can see here a reference if you want to see more about it. So finally, the publication aspect regards, okay, we should be able to connect with other similar infrastructures that exist now in Europe, but also in other parts of the world. And we should find a way also on link with other external initiatives, possibly also for the reuse of data for various, in various domains, not only research, but also education, industry, creative industries, and so forth. And this is directly related to sustainability of DigiLab. So in terms of requirements, there are some very basic ones regarding, for example, technical levels. We should be aligned with various principles and therefore develop an authentication and authorization interoperability framework. Define, and this is something very, very important, define a persistent identifier framework, ideally to be linked with the heritage assets persistent unique identifier, a kind of ID of the heritage asset under analysis. And then DOI assigned to a data set should be evaluated. Then a data access framework where data is perceived as a service, in particular for its reuse, and we are now linking directly to sustainability again. A service management and access framework where we have to consider ethics and intellectual property rights, and a support service. Then some very domain-specific requirements. Franco mentioned CRM HS. We mentioned several other CDOC extension, and we brought them here as well because, okay, they exist and we have to address them. Then we have to create an interdisciplinary metadata framework, including the script. So this is particularly important to have in one model both the heritage science workflow, but also the description of the asset itself. Renato made it very clear in his presentation as well. Then we should have internationally accepted protocols, which is a basic requirement when we want to talk about data provenance and data quality. And in some domains, it's very developed. In other fields of expertise, it's a bit less. Finally, an IPR management. And if we want to think in terms of sustainability, we should think about an open metrics framework for rewards and recognition on using DigiLab. Then we have to think about costing. Carla mentioned the weight of this data, and we have to consider it as well. Costing for the reuse of DigiLab data. Then we should have agreed upon policies at national level in each countries, and adopt data management plans at national or institutional levels. So I'm done. Okay, I will. Okay, can you hear me?
Yes, we can hear you, but I think we have finished our time.
Okay, I will stop sharing my screen. Yes, apparently. Okay, so we are, I just finished on time because we had some problems at the beginning.
Okay.
So we thank each other. Anyone is here? Or,
Yes.
Yeah.
okay.
Questions of people who are listening?
Well, I don't know what is going on because I don't have any feedback from the RTA organizers. So I don't know who connected or who is not. And maybe Franco mentioned that we were disconnected.
No, I don't think so. We have 15 attendees according to Zoom, and okay, we can discuss until they shut down our connection. I think we can continue if you want.
Mm-hmm.
Okay. I see myself. Okay, I unblocked now. Okay, we had also a comment from somebody. Okay, if you have some comments, please mention them.
I just added the links and my references to the chat. So if you want to know more, I had only 9 minutes, but if you want to know more, I will be glad to provide additional information. And we have reports, we have an extensive documentation if you are interested. Please email me or go to the Ariadne Plus website, which are both references are in the chat. Copy them because when they close this session, they will disappear.
Okay. I wanted to ask Carla.
Yes.
Something regarding protocols, because I saw in your presentation, you mentioned them, and I think it's something very important, but I also heard other opinions about the non-use, the need for not using protocols, and how this relates a bit with the quality of data.
Well, I think that the problem is if you have a well-established way of working, that works fine. For example, for EDS, quantitative analysis, the protocols work fine. So if you follow them, your data will be okay. But I can imagine other areas, it's quite difficult to build a protocol to be able to cope with all the process of the data. So one thing that I did not yet well looked into, but I have some colleagues which work with light microscopy. And I think that's might be quite hard. For example, if you have a shadow in the room or your light is not exactly the same, even if you use a reference chart or something like that. So you might have differences, and if you want to quantify something on that, I think that's quite difficult. I think several techniques might have difficulty in setting up protocols. I don't know if
this relates also to it relates also to environmental data, right?
Yeah, sure.
So I was also wondering if we were using these protocols whenever they exist, how do we link that to, or there are some vocabularies that address these protocols? So in a way to avoid then the problem of translations, and as we saw, we will get lost in translation. So if so, the question is if the protocols are linked somehow to existing vocabularies and thesauri.
Yeah, well, I think in the technical area it's easy because most of this it is in English. But I think we start getting problems like the example Franco gave about that part in between. You don't have it, so depending on what you describe, there are no words for it. So you have to either create a word, or what I sometimes tell my students, just to use the word, the original word, and comma. And I think it goes what was told by Juliana about a thesauri. So about a common language and what all those terms mean. So in technical areas like electron microscopy, crystallography, and so on, that's quite easy because we use just English. I think that the problem arises when you are describing very local aspects, and that's not an easy problem.
Okay. I wanted also to ask Juliana if in the vocabularies of the social sciences and the humanities that SHOC deals with,
Yes.
there is any reference to, if there is any reference or thinking of integrating vocabularies that are more, let's say, technical, that still it's part of the work of the domain, but as also Franco mentioned, archaeological sciences are part of archaeology at the end of the day. So if within these vocabularies of humanities and social sciences, there is an attempt to bring in terms from natural or exact sciences.
I'm not really sure because SHOC is a very big project. We have like 10 work packages, and there is even one task force that is working on cultural data heritage and also in archaeology. And I know that they're also investigating and collecting the existing vocabularies. As the project is very large. We haven't managed yet to gather all the requirements and come to, let's say, an agreed strategy of what exactly do we include in this inventory and which platform we will use to store and manage this vocabulary. So I think if you're interested in the project, please stay tuned. And I hope everything will become more clear in the upcoming deliverables from all these work packages. And about this project, I'm busy now with reporting and analysis and setting up more meetings with all the stakeholders to let's say, round up this project and have concrete results.
Yeah. Okay. Thank you.
If I may add,
and I'm sure. Yes, Franco.
A couple of words on protocols. There is a big problem which came up also during the IRIS review, that there are no so far no good semantic tools to describe protocols. So it's a problem not only because you have different depth of description, but also because it's there is no way of addressing this from a semantic perspective. You have ontologies for reports, for now you have for scientific data, but for the protocols it's still an open research field. So it's difficult to get to somewhere. People is working on that, but it will require some more time. So not just a matter of terminology, because once you have defined the concept, it's easy to get the useful terms for that in different languages. Of course, English is standard, but not for describing the light conditions. So you cannot force people to write in English that today it is a stormy weather in Cyprus. How do you say that? No way. So then it's a matter of understanding which are the fundamental concepts, and then the vocabularies will follow.
Okay. Thank you, Franco. I was also curious to hear a bit more from Renato, if he's still with us, about this concept of prescriptive dictionaries versus descriptive documentation. I think this is a very interesting subject.
It is a rather traditional distinction, and it comes from the time where national states started promoting dictionaries to fix the national languages. So the idea was that the dictionary made it commendable or even mandatory to use one term or one variant of a term instead of others. This, of course, was evolved in various ways to the notion that dictionaries should include the language that is actually used or spoken or written. And I mean, the thing I want to state is that as for scientific already fixed procedures, because probably the problem is when procedures are being set up, it's probably a bit too early to write the protocols, because then you freeze a process that should be creative. But once they are fixed, they are pretty much fixed, and the thing for translating them is to make the work of producing authority files that allow people to know what they're talking about. Instead, for museum or field heritage practice, I mean, for the archaeologist on the field, or for the person who is in the store of a museum actually updating the records, much more descriptive instruments would be more useful. We have very much the Nastrino problem, right? I mean that there are things, I mean, among Spanish-speaking countries, there are things that are that have different names. And in Latin American countries, we use words that that were used in Spain in the 17th century or so. So, I mean, we need more ethnographical instruments built from field research or I mean, from different sources to make sure that this Nastrino thing gets into the instrument, because that's a very good example. It comes from craft, from masonry and building and all that. That this vocabulary is very. I mean, it's it gets mixed with the popular language, and it is very fluid. So the aim, which I have seen in a number of handbooks and manuals, to have authority files to fix technique, might be of use when you have a very stable universe, but I mean, that is very rare. I have a question for Carla as well, if I may, because I mean, I was interested in the problem of the black box attached to the instrument, and wonder if, I mean, what strategies have you developed to deal with that, because it is a very serious problem.
Yeah, what's actually I normally do, I question the vendors a lot.
I believe it was Carla, yeah.
Yeah, so, it's the only way. And sometimes some vendors are open to that. And then if you work inside a community, it's just pressure on the vendors. So if you have technical reasons for that, and you question them, and if you are known in the community, you just are very open to people with when they ask your opinion. I'm just completely open. So I say, well, that software is no good because of that and that and that and that. And that gets into a snowball, and eventually they fix it. And the other thing that it's quite interesting that I have been saying to some colleagues, that most of the companies, they work with client satisfaction protocols within it's not ISO, but 17025 accreditation and so on. And one of the things is if the client is satisfied. So I think it's just pressure. And for example, Gatan, which is a producer of cameras, CCD cameras for electron microscopes, they used to charge you a lot to have the program to treat your data. A lot of people went over to ImageJ, which reads GM3, which is DM3, which is Gatan. And well, I think 2 or 3 years ago, Gatan just opened up the software for everyone to download. You still have to pay very big chunk if you want to have the camera and the software which drives the camera. But if you are going to treat your data, you get the software for free if you wish. So I think it's just pressure from the community to do things nicely in a good way, and competition is very healthy, I would say.
Thanks.
Okay, thank you. One short question to Wim, if he does, regarding users of HESIDA. If you monitor the activities and the access to the repository, because you mentioned science the metadata, and practically metadata is meant to provide a good access to such data. So I was wondering who are the users until now of HESIDA, who accessed it?
At the moment, no one. The repository is not public yet. So we have a repository, but it's only for testing purposes. The goal is to have it online in 3 years. So it's too early to tell.
Okay, thank you very much. Are there any other comments or questions? Okay, we have a comment. Actually, it's from Christian Zamora. You can read it in the chat. So hello, Christian. And also Catherine very kindly already answered. So thank you very much, Catherine. Any other questions? Because I think we're really going over our allocated time, and I don't think we should exploit too much RDA. So if there are no other comments and questions, I would like to thank you very much for the participation, and also either waking up very early or staying quite late in the evening for those here in Southern Europe. So at this I will say bye-bye, and we'll be in touch. Okay. Bye-bye.
Bye-bye. Bye, everybody.